In this video we are going to be looking at index notation, and this little graphic over here is a good example of what we're going to be looking at. The first thing we need to understand is that this number or this whole number or a pronumeral or whatever it happens to be is what we call the base, and this little number up the top which floats around, and it can be a 2, 3, 4, it can be any number, we normally refer to it as a power or an index or an exponent. So 3 different names for that little floating number there. The first thing we're going to look at is writing in an expanded form. So if we had b to the power of 3, we could actually write that as b times another b. Or if we had xy to the power of 3, we could write that as xy multiplied by xy multiplied by xy. And if we had 2a squared b squared, we could write that as 2 multiplied by a multiplied by a multiplied by b multiplied by b. So this 2 here is that 2 there. A squared is the same as a times a, and b squared is the same as b times b. Well, now that we know how to expand, how about evaluating these equations over here? Put the video on pause, give it a go, and come back when you're ready. Alright, well, the first one, so question A, 2 to the power of 4, can be written as 2 times 2 times 2 times 2. Where do I get that from? Well, 2 is my base number, which is that one. And 4 to the power of 4, the exponent of 4, means I've got to multiply my base number by 4 times. So 2 by 2 by 2 by another 2. So I've got 4 over there. So over here, I go 2 times 2 is 4, times 2 is 8, times 2 is 16, and therefore my answer would be 16. How do we go with B? Well, what I need to do here is I need to multiply my negative 2 by itself 4 times. And I'll write that like this. Minus 2 times minus 2 times minus 2 times minus 2. And remembering that when I do multiplication of numbers, if that's a negative, multiplied by another negative gives me a positive. Positive multiplied by a negative gives me a negative. And a negative multiplied by a positive is going to give me a positive value. So I'm just going to write it in that I know my answer is actually going to be of a positive value, not a negative value. And then I go 2 times 2 is 4, times 2 is 8, times 2 would give me the 16. And that would be my answer. How did you go with C? Well, remembering that this is a fraction, so we've got to multiply our fraction by itself 4 times. So we would get something like this. 1/2 multiplied by 1/2 multiplied by 1/2 multiplied by 1/2. So what have I done? I've actually multiplied a half by itself 4 times. And then I can simply multiply my numerators out and then my denominators out. So I get 1 times 1 times 1 times 1 is still going to be 1. And 2 times 2 is 4, times 2 is 8, times 2 would be 16. So my answer would be 1 over 16. Alright, if you know how to write in expanded form, we can take our expanded form and we can turn it back into index form. Looking at this expression over here, we need to turn this back into index form. So what we need to do is we need to collect our like terms. So where are some of our like terms? Well, that would be a like term because 3 and 2 are a like term. We could also have a look at x and x and x is a like term, and y would be by itself. So we could write that as 3 times 2 times x times x times x times y. And what I've done is I've collected all my like terms. The next thing I can do is I can go 3 by 2, and that would give me 6. And I would have 3 x's which are those over there. So that'll be x to the power of 3, and I have 1y. And that would be my answer. What about this over here? How do we collect all of these and write it in index form? Well, we simply identify our like terms. That's a like term, that's a like term, and that's a like term, as is a quarter and a quarter. So we can write that as follows. 1/3, and we'll put it in brackets. And how many thirds have we got? We've got 1, 2, 3, so that goes to the power of 3, multiplied by 1/4, and we've got 2 of those, and that would be our answer. The last thing we're going to look at is what we call prime factorization, or the factor tree. Here we want to take 24 and we want to break it down into its prime numbers. First thing we do is we create some branches, and we say to ourselves, what multiplied by something is going to give us 24? And the easiest one is obviously 2 multiplied by 12. 2 is a prime number, so we can't do anything with it anymore. However, 12 is still a composite number, and that can be broken down a little bit further. So we can go 2 multiplied by 6. And 2 once again is a prime number, but 6 is a composite, and we break 6 down into its prime numbers, and that'll be 2 and 3. So 2 and 3 now are prime numbers. Therefore 24 broken down into its prime numbers is going to be 2, and we've got 3 of those, so it's 2 to the power of 3 multiplied by 3. Alright, why don't you give this a go? Break 48 down into its prime numbers. Put the video on pause, come back when you're ready. Well, the first way I'll do it is this way. So this would be 8 multiplied by 6 is 48. And those are still composite numbers, so they can be broken down even further. So that becomes 2 and 4, because 2 times 4 is 8. So that now is a prime, and 4 obviously needs to be broken down into 2 and 2. So we now have some prime numbers there. However, this 6 over here can be broken down into 2 and 3, and that becomes our prime numbers over there. So 48 is equal to 2 to the power of 4 multiplied by 3. Right, well, there is a second way we can actually do this, which is this way. We can go 2 multiplied by 24 is 48. That's our first one. 24 can be broken down to 2 and 12. There's another prime number, but 12 is still a composite. That we can come 2 multiplied by 6, and that's a prime number, but 6 is still a composite. And then it becomes 2 multiplied by 3, and those there would be our prime numbers, and that therefore would be 2 to the power of 4 multiplied by 3, and that, as you can see, is exactly the same as this one over here. And that is index notation.